Assalamu alaikum wa rahmatullahi wa barakatuh. How are you, my dear students? Today, inshallah, we will start a new chapter, chapter 11. It is about motion, section 1, measuring motion. Pages 365 to 367. This is the half of the section. Inshallah, the second half we will explain tomorrow. Objectives: explain how is a frame of reference used to describe motion, differentiate between speed and velocity, calculate the speed of an object, explain how to study speed by using graphs. Observing motion. You may think that motion of an object is easy to detect by just looking at the object. No, it is not that easy. You really must to observe the object in relation to other objects around it. These objects must be in their place, fixed objects. Each fixed object is called a reference point. So, to describe the motion of an object, you should relate the motion of this object with other objects that have fixed position. We call this reference point. For example, here in the picture, we are comparing the movement of the car by the objects in fixed positions, or by how many reference points. Home is a reference point, tree, swing, light. We call this frame of reference. What is a frame of reference? A frame of reference is used to describe the motion of an object relative to reference points. For example, tree in the background can be used as a frame of reference to describe the motion of the car. When an object changes its position comparing to another fixed object, the object is in motion. How to describe motion? A complete description of motion should include two important things: direction and distance, and a reference point, of course. You can describe the direction of an object's motion with a reference direction. For example, describe the object is moving to north, south, east, or west, and so on. So, first, describe the direction of the moving object. Second, in addition to knowing direction, you need to know how far an object moves. Means the distance that this object traveled. Okay? So, to describe a motion of any object, you will describe the direction and the distance. What is distance? As we said, distance is how far an object moves. To measure distance, you measure the length of the path that object took. Look at the picture here. We measure the length of the path from starting point to the end point. From starting point to end point, this is the path or the distance that the object traveled. For example, if you start at your home and drift around your neighborhood, change directions a few times, the string that shows your path, this is the distance that you traveled. What is displacement? Displacement is the change in an object's motion. The line from the starting point directly to the end point that's shown here in the picture with black arrow, this is called displacement. So displacement, not the distance, it is the distance between start and end point directly. Okay? A line between the starting point and the end point directly, not the whole distance. Here the difference between distance and displacement. Distance measures how far an object moves along a path. Displacement measures how far it between the starting point and the end point. Displacement is shorter than distance traveled in most cases unless the motion is in a straight line. If the motion is in a straight line, the distance traveled equal to the displacement, the distance or the how far between the starting and the end point. The direction of displacement must also be given. What is the meaning of this? Now, the displacement between your home and the school with the blue line. This is displacement. Start point to end point. Okay? It is shown with blue arrow. The distance between your home and the school may be 12 blocks, but this information doesn't tell whether you are going toward or forward or away from your school. Displacement must always indicate direction. Means we should say the distance between the school and your home is 12 blocks toward the school. This is the displacement. Toward the school. We include the direction. Speed and velocity. What is speed? Speed describes how fast an object moves. So speed equals the distance traveled divided by the time taken to travel this distance. Distance versus time. This is the graph, distance versus time. Velocity tells about both speed and direction. Not only the speed and direction means the car is moving 60 kilometers per hour to the east. This is velocity. Velocity described relative to a reference point. This picture shows the difference between speed and velocity. Speed, how fast this car is moving. For example, 60 kilo per meter. Velocity, the speed in a given direction. This car is moving 60 kilo per meter to the east. Velocity. Direction is described as positive or negative along the line of motion. If a body is moving in one direction, this is positive velocity. If it is moving in the opposite direction, this is negative velocity. Look at the picture here. To the right, up and right, this is positive velocity. To the left, down and left are negative velocity. What happens when we combine velocities together to determine the final velocity? Look at the picture here. You have this example in your book. Now there is a bus. This bus is moving in this direction, the same direction, and also there is a boy inside the bus. Stand up and start to move in the same direction. The bus moving 15 meters per second to east. The boy also moving 1 meter per second to east. So to calculate the final velocity or the resultant velocity, we add 15 plus 1 equal to 16. This is the person resultant velocity. What happens if the person stand up and change his direction to the west, 1 meter per second to west, and the bus is still moving 15 meters per second to east? When we combine these two velocities to calculate the person velocity, we are subtracting the smaller one from the bigger one. So the person's resultant velocity is 15 meters per second east minus 1 meter per second to west equal 14 meters per second to east. We finished our lesson. Please read the lesson carefully, and inshallah we will complete tomorrow.